everyone. Good morning. Thanks for joining the live stream. If you are just joining, let me know in the comment section. We are glad to have you here. So, we will be answering some high yield physics question in this very live session. All right, so we'll be answering high yield physics questions in this very live stream. Okay, so if you've got any question as we progress, do well to let me know. Okay, if you are just let me know in the comment. Let me know in the comments. Okay, let me know in the comments so we get started. Thanks for joining. Thanks for joining. Okay, we'll be getting started right away. All right. Question number one is already on the board, so we'll be getting started with this. Like I said, if you are just joining, let me know in the comment. Let me know in the comment. Okay. So this is the question. It's read: in what range of temperature? In what range of temperature is the expansion of water anomalous? Okay, in what range of temperature is the expansion of water anomalous? That is the question. Okay, that is the question. If you are just joining, let me know so we progress. Now, there is something about this question you need to know. Now, water undergo expansion, but the expansion of water, like the question rightly said, is anomalous. So we will be starting with something we call the anomalous behavior. Okay, anomalous behavior of water. Anomalous behavior of water. Now there is something about it. Anomalous behavior of water. Anomalous behavior of water. So take note, that's what we are getting starting with. As you're joining, let me know in the comment. Okay, we are glad to have you guys on this page. So what is anomalous behavior of water? Normally, for ordinary substances apart from water, for other substances, be it liquid or solid, when you heat them, when their temperature is increased, okay, they tend to expand. Is it not? That is how normal substance behave. They tend to what? Expand. Their volume will increase and the density will reduce. Okay, but for water, the inverse is the case. The reverse is the case. For water, between a certain temperature, water will not follow the general rule. Okay, what is the general rule? When a substance is heated, temperature is increased, and as temperature is increased, volume increase, and as volume is increased, density will drop. Are you seeing that? Temperature is increasing, volume is increasing, but density will what? Drop. That is for normal substance. But water, between this temperature, between, okay, now we're giving some options. In what range will water be anomalous? Will water behave anomalous? Is it between 0 Kelvin and 4 Kelvin? Or between 0 degrees Celsius and 4 degrees Celsius? Or between minus 0 degrees Celsius and 0 degrees Celsius? Or between minus 4 Kelvin and 0 Kelvin? So that is the question. Between one of these, water will behave anomalous. Okay, now between what temperature will water behave anomalous? If you are just joining the live stream, let me know. Thanks for joining. Okay, so basically we are answering questions regarding topics in physics as they arise. Okay, just stay tuned because we'll be revising each of them as we progress. So for now, we are, because of this question, we are talking about anomalous behavior of water. Now between, take note, between 0 degrees Celsius, not 0 Kelvin. That is where it can get tricky. Imagine you remember the value between 0 degrees Celsius to 4 degrees Celsius. Imagine you remember the value 0 and 4. And you're not like, oh, is it Kelvin or Celsius? Take note, it is 0 degrees Celsius to 4 degrees Celsius. Between this temperature range, water we behave anomaly. Okay, we behave anomaly. We behave anomaly. Okay, let me just say anomalously, something like that. Yeah, now let's see what will happen between this temperature. Normally, like I said, when you heat a liquid or a substance, generally temperature will increase, right? And when that temperature increase, what happens to volume? Volume will increase. But between this temperature, this is what will happen. Volume will decrease. Volume will decrease. So water will now what? Start becoming more compact. Are you seeing that? So instead of expansion to occur, what will happen here? Contraction will occur. So whichever word they want to use, whether they will say water will contract or they will say volume will decrease, is the same thing we are talking about. If you are just joining, let me know. Thanks for staying put, guys. Don't forget to like the live stream and share with your friends if you have any. Okay, let's continue. Okay, apart from this, what will happen to density? Okay, density will increase. Now you see, this is the inverse. Normally when temperature is increased, volume is supposed to increase and density is supposed to what? Decrease. But we are seeing the inverse, and it only occurs between this temperature, guys, for water. Only for water. Okay, now how do we know density will increase? How do we know density will increase? Watch out. We know that density is mass over volume. This symbol is for density. It's like a key. Okay, if you are just joining, let me know in the live stream. Thanks for staying put, guys. Don't forget to like the live stream. Okay, let's progress. Now, how do we know density will increase? Now, if the value here, which is for volume, is becoming smaller, because the relationship between P and V is inverse. Watch it, they are not on the same, okay, part of the fraction. One is a numerator here, one is a denominator. So as this one is increasing, this one is decreasing. Or as this one is decreasing, this one will increase. Take note, that is why density will increase. So watch out, from 0 to 4, density is becoming what? Bigger, or let's say of more higher value. Now we now conclude that, note, water has its highest density at 4 degrees Celsius. Take note of this. It can also form a question on its own. At what temperature will water have its highest density? The answer is what? 4 degrees Celsius. It's just like saying, if you've seen a graph, okay, we can actually do that here and clean it. This is 0, okay, degrees Celsius, and this is 4 degrees Celsius. And beyond this is other temperatures. Beyond this, temperature will increase, let's say 100 degrees Celsius. Now this is the pattern. This is how it works. Temperature will increase, okay? Temperature will increase. What am I talking about here? And no, okay, wait, sorry. This is where all the temperature will be on this side, sorry. 4 degrees Celsius. Just stay put, we are working it out. Then this is 100 degrees Celsius. And this side, we will call it for density. This side is for density. So this is what normally happens for expansion of water. For expansion of water, this is what happens. Okay? Temperature, as the temperature is increasing from, okay, what do they call it? From 0 to 4, it will kind of peak up, okay? So at this 4, it's going to have the highest density. Are you seeing that? It's going to have the highest density. Beyond 4, as the temperature increases to this side, it will start dropping. Are you seeing that? So it's like trying to say that water will have the highest value for density at what? 4 degrees Celsius. At 4 degrees Celsius. So that is the explanation. Take note of that. Take note of that. Now, guys, we progress. If you have any question as we progress, do it to let me know. Alright? That is why we are here. Now, let's progress. There's something else to add for this. Now, this guy called anomalous behavior of water. Okay? It's studied using an apparatus. There's an apparatus used to study it. Now, the apparatus used for anomalous behavior, to study anomalous behavior of water, the apparatus we use is called the Opes apparatus. Take note. The apparatus used is Opes apparatus. Opes apparatus. Opes apparatus. This is H. This is H. Hopes apparatus, like as in, what do you call it? HOPEX, Hopes apparatus. And the experiment itself is called Hopes experiment. Just take note of that. All right. So we progress, guys. Over to the next question. Basically, this was just to explain something. It's not really part of the question. So what do you think will be the answer? Option A, option B, option C, or D? Without taking twice, we know that our answer is what? Option B. Option B. So that is the answer to the question. Very, very easy. Now we go straight to number 2. The question read, and we read together. They said, when the direction of vibration of the particles of a medium, emphasis on this, when the direction of vibration of the particles of a medium is parallel, we mark this, to the direction of travel of the wave. So we mark this. Now the wave transmitted is known as, so we are asked when the direction of vibration, okay, of a medium is parallel. This is the keyword we are working with. To the direction of travel of the wave. That wave that is transmitted, what is it called? A, is it called a stationary wave? B, is it called a longitudinal wave? C, is it called progressive wave? Or D, is it called a transverse wave? Let me know if you have an idea about the answer in the comments. If you've got any idea about what the answer will be, let me know, okay? Let me know if you've got an idea. But this is it, straight to the point, without wasting time. We are progressing. Okay? Now, when the direction of vibration is parallel, okay? Let's say direction of vibration is parallel. I will mark this parallel so you can know that it's highlighted. So, direction of wave travel. That wave is called, take note, in case you don't know, it's called a longitudinal wave. It's called a longitudinal wave. Take note, a longitudinal wave. So this is the first point. I'm basically giving you what each of them means. Now, if the other case is the inverse, if the direction of vibration is, what they call it, perpendicular, that's the word. Direction of vibration is perpendicular. What happens if it's perpendicular? So the direction of wave travel. Okay? Which of the wave will it be called? Will it be called stationary or transverse or progressive? Let me know in the comments. Direction of wave travel. Okay? Now this wave will be called, take notes, it will be called a transverse wave. So that is what it will be called, a transverse wave. So in case you were not asked longitudinal again, you were not asked for transverse wave, guys, take note that it will be what? Transverse wave. So this is the keyword we watch out for. They said parallel. So we know that when the wave is moving, should I say, parallel to the vibration, this is what they are saying. For this guy, the wave is vibrating. These are, it is usually shown for longitudinal wave. So let me write here, longitudinal wave. Longitudinal. So I'm just illustrating. This is the vibration of the medium. This one that is kind of compressed together. Okay? Then the wave will move like this. The wave is moving like this. So watch. Vibration. Progression of the wave. Let me use a line and indicate it. Progression of the wave. The wave is going in this direction, but the vibration is also what? In this direction. So they are moving parallel to each other. Wave vibration, wave travel in the same direction. That's why it's called longitudinal wave. But for this other guy, what do you call it? For transverse wave, it's kind of like this. The wave is progressing like this. Yeah. So while the wave itself is traveling in this direction, the particles of the medium is vibrating in this direction. So if you check up and down, while the wave is traveling like this, normally it's going like this. So as the particle of the medium is vibrating up, coming down, going up again, coming down. The wave itself is what moving in this direction. So if you check, it's kind of a right angle. Wave is vibrating like this, wave is traveling like this. So that is the difference between transverse and longitudinal. I hope that is clear. Emphasis on parallel and perpendicular. I hope that is clear to us. All right. So let's see what else. Now for this one, for what do you call it? Progressive wave. For progressive wave, what will you say about progressive wave? For progressive wave, energy is transferred. For progressive wave, energy is transferred. Energy is what? Transferred. Because the wave itself is what? Progressive. So energy must be what? Transferred. Energy is transferred. Then lastly, for what? Stationary wave. Let's see. For stationary wave, all right, energy is not transferred. So that is just, they are just like opposite side of each other. Energy is not transferred. Energy is not transferred. So guys, that is for that. That is for that. So take notes for this guy and this guy. Take note of them. All right. So basically, that is it. That is it. That is it for that. All right. So we will be going on to the next question. We will be going on to the next question on this side of the board. On this side of the board. I hope basically we've taken note of everything on the board, and perhaps you have learned one or two new things. So we progress. We progress. If you are just joining, let me know in the comment section. Say hi, and then if you haven't liked the live stream, don't forget to drop a like. Don't forget to drop a like. If you have a friend that ought to also be here, do it to share the live stream with him or her. Basically, we are moving on to question number 3. Question number 3. All right. So let's see what question number 3 will be like. So this is the question. Question 3. They said a concave mirror. So if you were here in yesterday live, you know I talked something about optics. You can check the live history. We did optics yesterday. Basically, I dropped some shortcut formulas for solving optics. A concave mirror of radius of curvature. Of radius of curvature. Let's see the value. Okay. What is the value? What is the value? 20 cm. Okay. Has a pin placed at, okay, 15 cm from its pole. So this is the question. They said, what will be the magnification? What will be the magnification? Let me just complete it. Of the image form. Of the image form. Alright, this is the question, guys. So that is the question. That is the question. So basically, we are asked to find magnification. And how are we going to do that? We were taught, what do you call it? Optics shortcut formula yesterday. So this will be a walkover for us. To be an easy walk, right? Because we already learned something about it yesterday. So let's see how we solve this. Kind of basic solution. Now, they said a concave mirror of focal length of radius of curvature 20 cm. As we read, we derive. Guys, they gave us radius of curvature. True or false? True. Radius of curvature, what is the symbol? Small r. They said the value for it is what? 20 cm. So this is for that. Now, if you're here yesterday, you should have been thinking of something right now because it's already easy, right? They said it has a pin placed at 15 cm from its post. So if this is the mirror, this is the pin. The pin is serving as what? Object or image. Is serving as the object, right? So the pin was placed in front of the mirror, 15 cm from the pole of the mirror. So that distance between the pin and the mirror, what do we call it? The object distance. The object distance. And the symbol for object distance is U. Okay, I hope we are basically following. If you've got any question, drop it in the comment, okay? Drop it in the comment section. So the distance between the pin and the mirror is the object distance, and the value for it as given, they said has a pin placed at 15 cm from its pole. So this is the value of the object distance, 15 cm. And the question is, what will be the magnification of the image of the mirror formed? So let's see. M is what we are looking for. Magnification. We don't know the value of our magnification, so we'll put question mark here. Now we have gotten this, we are almost done. I can tell you that for free. We are almost done. But guys, this is it. If you were here yesterday, you should be thinking of something already. I gave a number of formula for finding magnification, okay? Then I said something that sometimes, that is what we are actually doing now. Sometimes you might not be given the focal length directly, okay? The formulas I gave for magnification that have focal length, I said the formula I gave for magnification that has focal length, they are supposed to be the one we are going to use here, but we don't have focal length. Now, how do we get focal length? Can somebody tell me that in the comments? Let me see. Let's see. Do anybody have an idea what the answer will be? Now, to find focal length, this is the formula I gave. Because before we can find our magnification, we have to first of all get our focal length. And how do we get focal length? Focal length is equals to arrow over 2. So imagine I can remember this. I should be able to get the question, right? So this is the formula we use first. Let's get our focal length. In place of arrow, what will we write? We're going to write 20 over 2. Now guys, 20 divided by 2 is what? 10. So because it's 20 cm, I will say 10 cm. Now guys, there's supposed to be a sign in the front. The sign is either going to be plus or minus, because we said focal length can be plus or minus depending on whether the mirror is concave mirror or convex mirror. And we also said something like that for lens too. Concave lens and convex lens, they have their own signs too, is it not? Now check. If you're here yesterday, you can check. For concave mirror, we said that the focal length is always what? Is it positive or negative? We said yesterday that the focal length is always positive. So don't just put 10, because if it was a convex mirror, I'd have put what? Minus. Is always negative for convex mirror, but positive for concave mirror. So I don't just write 10 here, I will put plus 10. Guys, now I have this. I have now gotten my F. I have my U, because I'm no longer working with this. I use this to get this. I use this to get this. So guys, I have this, I have F, I have U, and I'm looking for M. What is the formula I'm going to use? Very simple. M, I gave it yesterday. M is equal to F over U minus F. Once I can remember this formula, trust me, I've already gotten my answer. Just remembering the formula, I've already gotten my answer. So let's solve. In place of F, what do we put? Plus 10. Plus 10 over, in place of U, what do we put? 15 minus, now mind you, we are working with F, and F is what? Plus 10. So I must indicate that it's positive 10. How will I do that? In bracket plus 10. This is what I'm going to do. I hope basically we understand up to that extent. Do we understand up to that extent? If you've got any question, let me know. Don't just watch without understanding everything we are teaching. So basically we progress from here. Plus 10, so now be plus 10 over, M will be equal to plus 10 over, guys, minus times plus is minus, okay? Minus times plus is minus. So it will now be what? 15 minus 10. That is what it will be. We get stuck to this extent, right? So moving on from here, we now have M equals to plus 10 over 15 minus 10 is what? 5. So we now say, so therefore, M is equals to what? Plus 10 divided by 5 is 2. And that is the answer to this question. Sometimes they might not write the signs, but in case they want to be extra, conscious of the question, they want to really test if you understand the question, they will put option A minus 2, option B plus 2. So you should know that the answer is what? Positive 2. If there was no sign, it will just be what? 2. Okay? I hope that is clear. I hope that is clear. Do we get that? So we move on to the next. If you've got any questions, indicate in the comments. So we are going on to question number 4. Basically, we are revising everything we've taught so far this week. Everything we've touched so far this week. So just stick together with me as we solve questions on them. Alright? If you are new to the channel, don't forget to drop a subscribe. Okay? You might not be notified if you are not a channel member next time. So subscribe so that when we go live next time, you will be duly notified. So you'll not just be hanging around. Alright? Alright, we progress right away. Question number 4. Alright, let's see what we have next. So let's take the next question, guys. But basically, I hope you understand what we are doing, guys. If you've got any question for me, let me know. Let me know so we progress. So this is question number 4 on this part of the board. Question 4. We rule, then we solve. He said, the eyes and steam point. You have to listen to this. This is under a topic we called thermometry. Okay? We write, the eyes and steam point. Alright? They add X. Of a mercury in glass thermometer. Mercury in glass thermometer. Okay, let's write this out. Correspond respectively to 3 cm and 19 cm length of the mercury thread. All this one does not matter. One thing about it, once you know the value, you should be able to solve the question. Basically, they will want to just construct a sentence. Just know the value, solve your question, then leave there. Okay? But basically, these are the bring questions out. They will just construct, what I call it, a sentence around it. They said, when the length is 12 cm, okay, what is the temperature? I think this marker is becoming fader. So we have to change it. Fader. Yeah, basically that. We are asked to find the temperature. Alright, so let me just write the options they give here. Option A, they said 32 degrees Celsius. Option B, they said 48 degrees Celsius. Let's change this sheet. Option C, they said 56 degrees Celsius. Option D, they said 65 degrees Celsius. So we have options and we are asked to solve. I hope we are still on the same page, guys. So let's continue. This is the question. The eyes and steam point of a mercury in glass thermometer correspond to 3 cm and correspond respectively to 3 cm and 90 cm length of the mercury thread. When the length is 12 cm, what is the temperature? When the length is 10 cm, what is the temperature? When the length is 12 cm, I mean. So this is its solution. Okay? Now this is how we draw it. I already know where the question is from. So basically, when you're studying physics, get to know where the questions are coming from as you progress. The topic is thermometry. So you can go and check it out yourself. Thermometry. Or they will say temperature and its measurement. That's how it is in most textbooks. But if you combine it together, it's saying what? Thermometry. The metry there stands for the measurement. While the thermo there is for what? Temperature. It's still the same thing. So basically, this is how we draw it. We will draw this scale like this. Basic approach. Now on this side, we know that they are working with what? A centigrade thermometer. They say the eyes and steam point of a mercury in glass thermometer correspond to this. Okay? 3 cm, 19 cm length of the mercury thread. Now the question is saying when the length is this, what is the temperature? Now, normally for a centigrade, when you check the options are in what? Degrees Celsius. Now, the ice point, you write it here. The steam point, you write it here. Are we together? They will now say on this side, they gives us the value. They say that that ice point corresponds to this guy. Okay? On this side, ice point corresponds to what? 3. Steam point corresponds to 19. So this is what I'll do. Just watch me. Ice point, starting with ice point, is 0 degrees Celsius using a degree Celsius thermometer. Steam point is 100 degrees Celsius. So when they say ice point, it actually means 0 degrees Celsius. Once you just see ice point next time, just know that it's what? 0 degrees Celsius. Once you see steam point, just know that it's what? 100 degrees Celsius. So they now say, respectively, these two guys correspond to what? Ice to 3, steam point to what? 19. Ice point to 3. So this 0 degrees Celsius correspond to 3 cm on this side. While the steam point correspond to what? 19 cm on this side. The ice point and steam point, 3 cm and 19. Are you seeing that? Ice to this, this to this. They now said when the length of the whatever this thermometer is 12 cm. So the one that has cm side, it's not this side that has cm side. So 12 will be between these two guys, three of us. 12 will be somewhere between 3 and 19. So I'll just come here and put it anywhere. Doesn't matter where you put it. I'll just put it here, 12 cm. When the length is this in cm, what is the temperature? So correspondingly, what will be the temperature? Do we know the value for it? No. So this is the symbol we use to leave it like that. We'll put theta. This is the symbol we use for the unknown temperature. We use theta. I hope we get it up to this very extent. Did we get it up to this very extent? So we progress from here. We move on from here. So we are going to use what they call interpolation method. Interpolation method. How do we do that? Watch out. Very, very easy. We are looking for this, right? We are looking for the unknown temperature. And it's corresponding to this. This is corresponding to this. This is corresponding to this, right? So this is the general rule. Whatever you are doing on this side, do the same thing on this side. Watch out. Whatever I am doing on this side, I will do the same thing on this side. Watch out. I will say theta minus 0. Leave all the degrees Celsius, leave all the cm. Work with the value only. Theta minus 0. Theta minus 0. Okay? I need this stuff. Theta minus 0, okay, over 100 minus 0. If you notice, I said middle minus lower over upper minus lower. Middle minus lower over what? Upper minus lower. I will do the same thing for this side. I will now say is equals to middle minus lower. 12 minus 3 over upper minus lower. Are you seeing I did the same thing? 19 minus 3. So it's the same thing for both sides. That's the general rule. Whatever you are doing on one side of the equation, do it to the other side of the equation. So what will it now be like? Any number, 0 away from any number. You are removing 0 from any number, it will be the same thing. So theta minus 0 is theta over 100 minus 0 is 100. It will be equals to 12 minus 3 is 9, right? 9 over 19 minus 3 is 16. So because you are looking for what? Theta. We'll make theta subject of this equation. This guy will times this. 100 times this. So it will now be theta will be equals to 100 times this. 100 times 9 over 16. Whatever we get will be in what? Because the value for theta is on this side. So the unit for on this side will be what we add. So whatever we get, we put in what? Degrees Celsius. Whatever we get as our answer will be in, because the unit on this side. degrees Celsius because that's where the theta is. So let's do that. 100 times 9, 100 times 9 is 900. Divide that with 16, it gives us 56.25 equals 56.25, like I said, degree Celsius, degree C, degree Celsius. So approximately, which of them is our answer? Option C, and that is the answer to the question. Very easy. The general rule is this. Provided you are able to decode the question, that ice point is the same thing as 0 degrees Celsius. So if they did not tell you the ice point and steam point, just know that this is 0 degrees Celsius and 100 degrees Celsius. So 0 is corresponding to this, 100 is corresponding to this, 0 is corresponding to 3, 100 is corresponding to what? 19. So you now say on this side, if the length is 12, because this side I have cm, if the length is 12, 12 is between this, so I'll put it in between. Then I say, what is the corresponding temperature? Theta on this side is unknown, so I'll put it as theta. The general rule is this. Middle minus lower over upper minus lower. I repeat, middle minus lower over upper minus lower. On this same side, the same thing. Middle minus lower, 12 minus 3 over upper minus lower. This minus this. Solve, you get your answer. Very, very simple. That is generally thermometry. That is generally thermometry. Their questions are not usually hard. So straight to the next question. We are into wasting time on these. So we'll take the next question 5 on this part of the board. If you've got any question, like I said, drop it in the comment section. I don't bite. If you've got any question, drop it in the comment section. Basically, I suppose we are following and that the explanation is clear. If I'm too fast, let me know. Okay, if you are not comfortable with the speed of my speech, let me know. Okay, I'll definitely adjust, and that's it. All right, let's progress. Question number 5. Let's see what we have here, guys. Kind of easy. They said, question 5. In which of the following, let's cover this. In which of the following, okay, is the molecules of water moving faster? So this is the question. We add our question mark. Let's see our options. We need it to solve. They said option A, ice. Option B, ice water mixture. Ice water mixture. Ice water mixture. Option C, they said steam. Option D, they said water. Option E, they said water steam mixture. So guys, this is the question we are asked to solve. Very, very easy and simple. Okay guys, I hope we are still on the same page. Okay, I hope basically we are on the same page. Have we got any question? If you've got any question, let me know. All right, so let's continue. This is the question we are asked to solve. Now basically this is talking about where will I put it now? Expansion of water under thermometry too. We are talking about boiling point and melting point. Okay, now this is it. When water is heated from the ice state, which is the first state, you take ice block and you start heating it. That water will pass through 5 phases before it becomes steam. Take note, when water is heated, we have to just write things, right? So that you can always go through it later. I don't want to just be saying it without writing it. NB, when water in the solid state is heated, it passes through 5 stages. It passes through 5 phases. Let's call it phases. Let's see what we have here. What are the 5 phases? You take water in the solid state. Water in the solid state is simply what? Ice, is it not? So this is ice. Guys, you eat ice. When you heat ice, it will go to the next phase. It will become a mixture. They call that mixture ice water mixture. Ice water mixture. This is the next phase. When you keep heating again, it will become water. So if in this stage it was what? Transiting. We call this the transiting phase. It was changing from ice to water, but the transition was not complete, right? But now it's now completely water. I hope that's clear. Now this water will now transit again. So water steam mixture is about to transit into what, guys? What is it going to transit into? From here, it's going to transit into what? They will become what? Steam. Kind of simple, right? This is the 5 phase that water undergo when it's being heated from the solid phase to the gaseous phase. So this is the solid phase. This is solid form. This, like we know, is the liquid form. Liquid form. And this is the what? Gaseous form. Take note, take note, take note of this. Or you say solid, liquid, and gas. Anyone you want to use. Now, generally, as we heat downward, what will happen to the molecule that make up water? What will happen to them? Initially, they were in a solid form. They were kind of more compact, right? Because in solid, you say that the force between the molecules of the solid is strongest. So they cannot really move around, is it not? So the velocity of the molecules in this state is very small. In fact, it's the smallest if you compare it to the others. If you compare it to the other phases, they have the least velocity here. Now, when you keep heating gradually to this down phase, the last phase, which is the gaseous or the steam phase, the molecular velocity will be what? Increasing. So as we keep heating downward, we will now add here velocity increases. That is what we are going to add. Take note of this. Take note of that. Take note of that. I hope we get that. Did we get it? That is it. Velocity will what? Increase. So guys, which of these 5 phases have the least velocity? Answer is what? Ice phase. Which of these phases have the what I call it? The highest velocity? The answer is what? The steam phase. So for this question, in which of the following is the molecule of water moving faster or fastest? I think that was what they wrote. Fastest. Fastest. Sorry. In which of these phases of water is the molecule moving very fast or fastest? Guys, what's the answer? The answer is what? The steam phase. So that will be what? Option C. And that is the answer to the question. Just stay put with me. Basically, when you note this one, you note from this end, you note from this topic in physics, you note from this topic in physics. You are actually building your brain, okay? When I'm explaining and you are noting from different topics, it will go a long way. Sometimes we don't have to just study one topic per live session. It's good we touch every aspect. I hope this is clear to us. I hope this is clear to us. So on this side of the board, we are going on to the next question number 5. Or sorry, 6. Question 6. We will be studying question 6 on this part of the board. So just stay put as we progress. Stay put as we progress. So let's see what the next question will basically be. What will be our next question? What will be our next question? Guys, let's see. Kind of easy now. Alright guys, this is the next question. They said number 6, a prism whose refracting angle, okay, is 60 degrees cause a minimum deviation of 48 degrees. This is getting further. Let's change it. Let's kind of refill it. All right. If you've got any questions so far, let me know in the comment section. Let me know in the comment section. Have we got any question? Have we got any question? So we progress. We're about to solve. This question is from glass prism. Refractive angle of glass prism. Okay. Once you know the formula, you should be good to go. Once you know the formula, you should be good to go. All right. So let's refill the other one too, so that we won't have to be refilling it again. All right. This is the question we are asked to solve, and it's from what? Refractive angle of a glass prism. This is not mirror, this is not lens, this is prism, and it's also part of optics. But generally, question on optics either falls to mirror or lens, or like I said, there's also pinhole camera, and like we are doing now, prism. So take notes. Let's see what the answer to this question will be. All right. They said a prism whose refracting angle, sorry, I didn't add it, I just noticed it now, whose refractive angle is 60 degrees cause a minimum deviation of 48 index. We are asked to find refractive index of the what? The prism. So like I said, the topic is refractive index of glass prism. Now straight to the point. First thing first, everything that was given in the question, we are going to derive them. Everything that was given in this question, we will derive them first. They said a prism whose refractive index is 60 degrees. So first thing first, what are we giving? We're giving refractive angle. Sorry, refracting angle. And the symbol for refracting angle is A. Okay, they say the value for refracting angle as given is what? 60 degrees. Are we still together? Now it now said this mirror that have this refracting angle, a minimum deviation. This is the word, minimum deviation. Is a physical quantity on its own, and the symbol for minimum deviation is capital D, then you spell MIN. That is minimum deviation. Okay? In some other textbook, they can just leave it as capital D. There's no need to add the MIN. You see the same thing. Whether I give it's still the same thing I'm talking about. They said the value for the minimum deviation is 48 degrees. And the question here is that we should what? Calculate refractive index. And if we were here yesterday or in previous live session, refractive index, the symbol is what? Small n. Okay, in this case, we don't know the value for it. Is that not? That's true. Now, for glass prism, to find refractive index, the formula we use is n equals sine half in brackets a plus d minimum, okay, over sine half a. It's kind of long, right? But I can tell you it's very simple. It's simple if you know the formula. This is the formula for what? Finding the refractive index of glass prism. Take notes. Take notes. Refractive of glass prism. This is the formula we work with. So basically, you should know the two values of the angle and the value of the angle of the refracting angle. Sum them up, divide by 2. Take the sign of the answer. Divide by 2, take the sign of the answer. The answer you got for up and down, you divide each other, you get your n. So let's do that now. N will be equals to, we're just imputing and substituting. Sine 1 over 2 in brackets. This plus this, we have what? A is 60. 60 plus, what is D minimum? Is what? 48 over sine. What do we get for A? 1 over 2. What is our A? Our A is what? 60. So times 60. Let me put it like this. Did we understand it up to this very extent? Did we? Hope we got it up to this very extent. Hope we got it up to this very extent. So we will be progressing right away. We'll be progressing right away. So from here, it will now be n equals to sine. So what I will simply do, guys, I want to make sure that we are able to use this part of the board to solve. This plus this, let's get it. 60 plus 48. 60 plus 48. 60 plus 48 give us 108. Okay? So 108 is what we now have here. Should we write that out separately? Let's write it out. 1 all over 2, like you can see here, times 108 over sine 1 all over 2 times what? 60. So this is what we are going to be doing now. N will now be equals to, watch out, half of 108, we will take that. Half of 108 is what? That is, this times this, 108, divided by 2. It gives us sine 54 over, watch out, half of 60. Half of 60, like we know, is what? 30. So over what? Sine 30 over sine 30. So this is what we are working with, guys. Over sine 30. So from here, we now say is equals to, now we need a calculator to get the sine of 54 and the sine of 30. We need a calculator for that. If you have any question, let me know in the comment, okay? So let's get the sine of 54. Sine of 54. Sine 54. Sine 54 gives us, so 4dp to 4dp, it gives us 0.809 over sine 30. Sine of 30, it gives us 0.5. So these are the two values we have. What do we simply do from here? The value of this divided by this. So we get our refractive index. 0.809 divided by 0.5. We have to 2dp. To 2dp we have 1.62. And guys, this is the value for the refractive index of the glass prism. And that is the answer to the question. Very simple. Provided you know the formula for the refractive index of a glass prism, which is sine 1 over 2 in brackets a plus d minimum over sine 1 over 2a, you can get your answers. I hope that is clear to us. If you have your questions, drop it in the comments so we attend to them. Alright? So for now, let me just check if anybody's got any question. If you have your questions, let me know. Okay? So we progress right away to the next question. So I'll be cleaning this out of the board, so we take the next question. Alright, let's see this question. Alright, let's see. So this is the next question we are asked to solve. Question number 7. We clean this part of the board and make use of this part of the board. If you've got your question, like I said, drop it in the comment. Don't just leave your doubts unsolved, okay? Let them be made known so we attend to them. Make them known so we attend to them. So this is the next question we are going to be solved. That will be question number 7. Question number 7. Alright, so this is the next question. You already solved the one on refractive angle. You already solved that. Alright, let's take this question. Let's take this question on refractive angle also. But let's see how the question will be structured. This is the question, guys. Question number 7. They said the speed of light, okay, in vacuum, alright, let's see what the value is, like we all know, is 3 times 10 raised to power 8 meter per second. Then I said if the refractive index, so we're giving refractive index directly in this question. If the refractive index, okay, is 4 over 3, 4 over 3. What is the question? Then the speed of light in the liquid is, so we are asked to find speed of light in the liquid. We're given the refractive index of a liquid. If the refractive index of a liquid, is 4 over 3, the speed of light in the liquid will be what? Unknown. So if you have any question regarding what we have done so far, let me know. So basically, we are going to be solving this question right away. They said the speed of light in vacuum is 3 times 10 raised to the power 8. So that is speed of light in vacuum. Okay, and like we know, speed of light in vacuum has a symbol, that is small c. So the value for it, like they gave, is what? 3 times 10 raised to the power 8 meter per second. Are we still together? Then I said, if the refractive index of a liquid is this, so we're giving refractive index of a liquid. What is the symbol for refractive index? It's small n. They said the refractive index of the liquid is what? 4 over 3. So we'll say 4 over 3. Then I said, then the speed of light in the liquid. Now, we are not talking about the speed of light in vacuum. Vacuum is empty space. We're talking about the speed of light in a medium, which is the liquid. So what symbol can we use to represent speed in this case? We can use V for what? Velocity. Okay? So the speed in the liquid is what we are looking for. Speed in vacuum, C. Speed in a medium, be it solid, liquid, or gas, V. Get that straight. So this is what? Unknown. Now, simple. For speed of light, okay, when you are giving refractive index, this is the formula to use. Refractive index is equals to C over V. This is the formula we are working with. Refractive index is equals to C over V, where C is the speed in vacuum. So let me add it here. C is equals to what? Speed of light in vacuum, all right? Then V is what? Speed of light, all right, in medium. So be it solid, liquid, or gas medium, V will stand for the speed of light in the medium, and it's V we are looking for in this very question. How do we find our V? Now we have our formula. This is our formula, our working formula. What do we do next? We substitute the value for C, N, and find V. Let's do that right away. In place of N, we write what? 4 over 3. 4 over 3, okay? We say it's equals to, in place of C, we write what? 3 times 10 raised to the power 8 over, in place of V, do we have a value for V? No value for V. So V will remain V. Do we get it up to that very extent? Let me know in the comments if you get it up to that extent. So what do we do from here? We are having a fraction on this side and a fraction on this side. And we are looking for V. So we what? Divide both, what I say? We cross multiply, is it not? Let's cross multiply. 4 with times V. 4 times V is equals to 3 with times this. 3 times 10 raised to the power 8. And like we know, we are looking for V, not 4 times V. So how do we make V stand on its own? Divide both sides by whatever is in front of V. And that's what? 4. So over 4 over 4. So what we have on this side is very simple. Watch out. On this side of the equation, this we just cancel this. So what do you notice is left? We have what? V left on this side of the equation. So basically, I want to just get my answer straight. Watch how I'm going to get my answer. We'll say 3 times 3. 3 times 3 is what? 9. Now that 9 we got divided by 4. 9 divided by 4. 9 divided by 4 is 2.25. So I'll come and write 2.25. Now remember we did not use this side, times 10 raised to power 8. We did not touch it. Is it not? So I'll come and add times 10 raised to power 8. I hope that is clear. And because it's also what? A form of speed. Velocity is also speed. So the unit will be the same as this. So what's the unit, guys? Meter per second. So can you see that it's very easy? The question we are solving is practically easy. Just know how to. Physics is very easy, guys. Listen up. Physics is very simple. First of all, you should know how to derive all that was given in a question. That's what we did. You should be good at that. Next, you should know the right formula to use. Perhaps some topics have numerous formula per topic. You should know the right one to pick. That what we picked out. In this same refractive index, there are other formulas you can actually use. But this is the correct one for this question. Next, you should know how to what substitute. That's what we did. Putting the what values into their right physical quantity. In place of n, we put this. Next, you should know how to what manipulate. We made v subject. That's manipulation. And then you get your answer. So, be able to what derive, be able to pick the correct formula, be able to substitute, and be able to what manipulate. We always get your answer. Check, it's the same thing we do. We derive, we pick the right formula, we manipulate, we what? We substitute first, that means putting the values into the equation, then we manipulate and get our answer. Very, very simple. That's physics. Just those 4 steps, nothing else. So guys, we'll be moving on to the next question. Do we understand what is on the board? Do we get what is on the board? Yeah, that's great. So we progress. So question number 8 coming out right away. Let's see what the question is before us. Question number 8. So I'm basically cleaning this part off the board. Let's see what the question will be like. Okay. So this is the question we are asked to solve. So this one, let's take it. Let's take this question. They said number 8. This will be our question 8, guys. So what is the question? They said, how long will it take, to heat 2 kg of water from 25 degrees Celsius to 100 degrees Celsius in an electric kettle. So we're told something very important. Electricity was used, is it not? In an electric kettle, which takes 5 ampere from a 220 volt supply. So this is the question, guys. And we're asked to take SHC of water. They said is 4180 joule per kilogram per Kelvin. So this is the question. Forget about the length. You shouldn't be scared of the length of any question you are giving. Okay, that's how it always comes. Like I said, just follow the rules. Follow the rules of physics, you will get your answer. So basically, I hope we get the question. I hope we get this question. Let's attempt the question right away. So we'll say solution. Now for this question, first thing first, where is this question taken from? The topic is calorimetry. As different from the first one we made mention of, thermometry. Now this guy, in some textbook, they will say heat and its measurement. Heat and its measurement is the same thing as what? Calorimetry. Now that's for that, in case you want to do your own further study. Now, like I said, you are given a physics question. What should we do first? Let's derive all that was given in this question. So we read and we derive. They said, how long? So the question, what you are asked to find is part of what you should derive. What am I saying? You are asked to find something. Let's say calculate the time. That t for time should be part of what you should add to the derivation list. Is it not? So where they said how long, it means that we don't know the time it will take, right? So t should be part of the what? Derived quantities. But in this case, we now add that it is what? Unknown. We don't know the value yet for it. So this is first derivation. How long t is unknown. Get that? Will it take to heat 2 kg of water? Kg stands for mass, is it not? So mass was given. N is what? 2 kg. They now said of water from 25 degrees Celsius, the initial temperature, to 100 degrees Celsius, the final temperature. So we have theta 1 and theta 2. I hope that is clear. So this is our theta 1, the first guy. Theta 1 is 25 degrees Celsius. So what? They said from 25 to 100. So our theta 2, which is our final temperature, is what? 100 degrees Celsius. He said in an electric kettle. So we're told something here. Electricity was used. Is it not? Because it's an electric kettle. It works by electricity. Now he now said in an electric kettle which takes 5 ampere. Ampere is the unit for what? Current. You should have known if you have been following the live session. Very, very easy. Now, ampere is the unit for current. Now, we saw that the current in this case, current is symbolized by I. I. He said the current is 5A, 5 ampere. Then I said which takes 5 ampere from a 220 volt. Volt is the unit for what? Potential difference. Simply V of voltage. They said the value for the voltage is what? 220 volts. Whether you call it volts or potential difference is the same thing. They said the value for it is 220 volts. And we're told something that SHC of water, which is what is being heated, SHC of water was given to be what? 4180 joule per kg per Kelvin. Now we see something here. These are all we have from this question. So first step have been passed, which is what? Derive what that was given in the question. What is the next step? What is the right formula we're going to use? That is the next question that should come to mind. Now if you have studied calorimetry in detail, okay? Now there are different methods of studying calorimetry. There's one that's called the electric method, which is what is being described here. You heat the, whether it's a liquid, in this case a liquid, you heat the liquid and observe the time it takes to transit from a certain temperature to another temperature. You also take note of the current and the voltage. Now, what is the formula we are going to use? We know that the temperature, the electricity, we have to calculate the energy that the, the 220 volts will give us. The energy can be gotten by this formula. Why did I use this formula? Because we're given I, we're given V, and we're asked to find T. IVT is one of the formula for finding heat energy. True or false? True. Now we then know that this energy that was gotten from the electricity is what will now be used to heat the water in the kettle. So that water itself will now what? Be heated. And the energy that will be used up by the water, there's another formula to get it. The formula is mc delta theta. Okay? Now because we're not giving the delta theta directly, we're giving the first and second temperature. I will now add this thing instead. Let me now write it. Why did I say this is equals to this? Because this is the amount of energy that is coming from the electricity that will be used to heat the water. So they should be equal. So this is what I will now pick. I will pick this, I will pick this. I will now write IVT equals what? MC. Now in this second case, I'm not going to write, okay, let me just, instead of doing this separately, to save space, right? We have gotten our formula. This is the formula we are using. How do I know? The amount of electricity getting to the kettle is the amount of energy that is used to heat the water. The amount of electrical energy, IVT, getting to the kettle is the amount of heat energy used to heat the water. So electrical energy is being converted to what? Heat energy. So instead of V, now we have already gotten our formula. Let's substitute. Instead of I, we'll put what? 5. 5 times. I hope we are following basically. Are we following? I trust we are following. Instead of V, we'll put what? 220. 220. Now, do we have a value for T? No value. So leave it as what? T equals to. Now, instead of M, do we have a value for that? 2. Now, observe something. Sometimes you might be given the mass in gram. It's not all time to just put the value like that. Check something. Mass in kg. In the value for specific heat capacity. Okay, let me write the meaning here in case you are just seeing it for the first time. Specific heat capacity. That is what it stands for. Okay. Now, the value for, or the unit for your specific heat capacity must agree with the unit for your mass. I repeat, the unit for your specific heat capacity must agree with the unit for your mass. So we're giving mass in kg, and in the unit for our specific heat capacity, we're told joule per what? Kg. So kg. That is the reason why I'm putting it directly as 2. If not, I would have convert. If I was given in gram, I will convert it to what? Kg before I impute it here. It's just like saying joule per kilogram per Kelvin. So the mass must also be in what? Kilogram. Clear? Good. So what is the value for our C, which is our specific heat capacity? So take note. Either you call it specific heat capacity, SHC, or you call it C. It's the same thing. SHC or C of water is the same thing. Now what's the value for it? They said it's 4180. 4180. Now this will be done smartly. We are asked to add the value for delta theta. Delta theta is the change in temperature. So we're told from this question that the water was heated from where? 25 to 100. So what is the temperature change? How do we get it? Final temperature minus what? Initial temperature. We will do that somewhere else. Delta theta is equals to theta 2 minus theta 1. What is our theta 2? 100 minus 25. 100 minus 25. That gives us what? 75. So we put 75 here. It's easy. If you already know your formula, you can be very, very fast with this thing. Physics is just, don't run from it. Just be watching it. If the question is your first time solving it, keep watching it and look for a possible way of solving the question. Don't ever run from any physics topic. It's all easy. In the end, you will see that it's easy. Okay? So let's see what we can do now. We'll need a calculator here. So we times these two together. Right? Or we can just simply do something. Let's do something that is very, very strategic here. We are looking for T. Is it not? Not 5 times 220 times T. So everything in front of T, we use it to divide both sides. What do we have in front of T? 5 times 220. So we say over 5 times 220 over 5 times 220. Are you seeing that? So 5 we cancel to 5, 220 we cancel 220. What is left in front? Just T. So say T is equals to 2, everything that is there, I'm writing it again, 4180 times 75 over 5 times 220. 5 times 220. So let's get an answer for this. So basically, I'll just say T is equals to, alright? everything up times 2 times 4, 180. Are you seeing that? Times 75. It gives me 627,000. So I'll write 627,000 over 5 times 220. 5 times 220. It gives me 1100. Okay? So let's do the division and get our answer. Very simple from here. So 627,000 30 divided by 1100. Guys, our answer is exactly 570. And because we are asked to find time and we stick to the right unit, kilogram and kilogram, the unit for time we write is what? What's the unit for time? Seconds. Now you might be asked, in most cases, they might not give it in seconds. They might give it in minutes. They can even give it in hours. So let's convert and get the theory value. Okay? The answer is this, or the answer is also, how do we convert to minutes? Divide this value by 60. 570 divided by 60. The answer can also be what? Okay, let me add it here. Or the answer can be 9.5 minutes, depending on the options. So that is the answer for this very question. Like you can see, it's very, very simple. Know how to what? Find your formula. First of all, like I said, know where the topic is from. Basically, know how to derive. You see, when we derive, we go to this place. It was long. So that's what happened. Sometimes students are just faced with the question. By just the length of the question, you're already scared. It's easy. You know, that was how David was able to confront Goliath. He was not scared of his what? His size. Is he not? So don't be scared of the length of the question. Imagine, were we not able to get our answer? Yes. If we had run from the question, we would have just left it like that. Derive everything that was given in the question. Know the right formula to use. Impute what I call substitute into the formula. We were putting in place of I, put the values. Then manipulate, make T subject. Then answer with what? Follow. I hope that is clear. That is for that. Very, very simple. That is for that. Very, very easy. So we go on to the next question. Go on to the next question. If you don't understand this, let me know. Let me know so we progress. Have we got any question regarding this calorimetry? If you have a questions, drop it in the comment section. We will get them attended to. Alright, let's go to question number 9. Question number 9. Question number 9 is about coming out. So let's see what we have for question number 9. So for question number 9, we are asked to find something else. Something else. So this is the question we are asked to solve. Alright, let's say this question. The question is on sound wave. Sound wave. So they said a man clapping his hand. Like I said, for this question, they are always kind of, most times, if they want to really mean you, they'll make it long. Don't be scared of the question's length. Clap his hands at regular interval. All this one did not concern us. We don't need them to solve our question. Okay? At regular intervals, observe that the echo, once I see this word, you should know something about this question. The echo of a clap correspond or coincides with the next clap. Now, what is the question? If the reflecting cliff, okay, is
160 meter away. Now here come the question. And the speed of sound is, we're giving it to be what? 320 meter per second. Now what is the question? What is the frequency? What is the frequency of what? Of the clapping. What is the frequency of the clapping? Now, this is a typical example of don't judge a book by its cover. By me looking at the size of this question, we are like, oh, we can't solve it. But that is erroneous to think. Very, very erroneous. Now, observe, what do we really need from all these questions? Just the value. And how many value were we giving? 1, 2. Just read through the question, then use your 2 value to get your answer. The rest is just stories. So don't be scared by the length of any question. Pick the values and solve. So let's read and solve. Solution. Now they said a man clapping his hand at regular interval like this. Notice that the echo of the first clap coincides with the next. Now this is what they call determination of the velocity of sound in air by echo method. I repeat, determination of the velocity of sound in air by echo method. That's why when I saw the word echo, I quickly underline it. Now when you just know that this question is about velocity of sound by echo method, there is one formula that is there. That's why you have to be good in your physics. Know the formulas too. As you are reading through your textbook, be noting formulas. Okay? Under echo method for finding velocity of sound, there is a formula to use. Okay? But before we do that, let's derive, right? Notice that the echo of his first clap coincides with the next clap. Now, that does not matter. There's no value so far, is it not? If the reflecting cliff, because it was clapping in front of like a, let's say a high, let's say a fence, a mountainside, so the clap will go to the, what they call this side walk. This is the man. Let me just demonstrate it. This is the man. He was clapping his hand. Okay? Clapping his hand. Let me do this. No, you clap, it bounces, clapping your hand, in front of this cliff. This is a cliff, like a wall. Now we know that the sound will go this way, and the sound will get what? Reflected back to him. It is the reflected sound we call what yesterday? Echo. Reflected sound is called what? Echo. So if you check, this distance was covered twice by that sound. It went and it returned, right? That is how to find sound by echo method. Now because of this, there's a formula we use. But before that, let's see. They say if the reflecting cliff, this is the wall. If the reflecting cliff, okay, is what? 160 meter away. So we're giving the value for x. X is what? 160 meter. Or you call it d, distance. The same thing, okay? X or d. If the reflecting cliff is 160 meter away and the speed of sound in air, so we're giving the velocity of sound to be what? 320 meter per seconds. What is the question? What is the frequency of the clapping? F is unknown. F for frequency. F for frequency. Now this is it. This is it. This is it. Now for echo method, find the velocity of sound in air by echo method. If you have your questions, let me know. If you have any question, let me know. Okay? Now this is it. For finding velocity of sound, V, the formula to use for echo method, velocity of sound by echo method. This is the formula to use by echo method. All right, it's V equals to, let me just call this distance, guys. Let me call that D. Okay, but in some terms they can also use X. So that's what I'm just saying. Distance from the what do you call it? The cliff distance. So that you can just, because this is your first time, if perhaps, so you will not go and get confused. The formula is 2D over T. This is the formula. This is the formula. Velocity of sound by echo method. This is the formula. This is the formula. Take notes. For finding velocity of sound by echo method. So guys, were we giving D? Yes. Were we giving V? Yes. Do we have T? No. Rather, we have to find what? We have to find frequency. And we can surely get that using some kind of formula. First thing first, we'll get T. And from T, we'll get frequency. So let's get our T first. Okay? Once we have T, T is the same thing as period. T, time or what? Period. Once we have T, we can convert to frequency. So let's find T. We can say, in place of V, we'll put what? 320 equals, what is this? 2 times, what's our D? 160 over, what is our T? What is our T? Our T is unknown. So make T subject, cross multiply. T will be equals to 2 times 160 over 320. So we'll do this with our calculator and get our answer. 2 times 160. 2 times 160 is 320. Divided by this same 320 is also is 1, exactly 1. So our time in seconds is 1 second, right? This is time or period. Where T is what? Time or period. T is time or period. So guys, how do we now get our what? Our frequency. There is a formula under wave we can use to get our frequency. Okay, the formula is F equals 1 over T or capital T, any of them. So we put it into this formula. We say 1 divided by, what's our T? 1. So therefore our frequency for this very question is T1. But that does not mean that it's for all cases. Okay? If here was 2, the value will be different. If here was 5, the value will be different. So 1 divided by 1 just gives us what? 1. And what is the unit for frequency? What is the unit for frequency? The unit is Hz. Hertz. Hertz. So this is the spelling. Hertz. Hertz. This is the unit for what? Frequency. Take note, and that is the value to this very question. It's very, very easy. It's not difficult. So like I said, if you've got your question, let me know. Let me know. So that's for that. We go on to the next question without delay. We go on to the next question without delay. Alright? Then quickly go and drink water, kind of dehydrated. Alright, let's take the next question. Let's see the next question on this part of the board. Physics is never hard, it's easy. Keep solving it, keep trying it. It will definitely play out well one day. Okay? Everybody you think that can solve physics, your tutor, your school teachers, whatever you call them, they all had the same fear like you had before. Oh, it could be hard. Oh, I don't understand it. Oh, I am not getting it. Oh, I'm failing it. You know, it will always be there at the initial stage, but that does not mean you should give up. Anything that comes that way always starts with a rough beginning. So don't give up. If you are finding it difficult, like I said, keep solving it. It will turn out well. So let's see what we have for question number 10. That is the next question we are going straight to. That's the next question we are going straight to. Okay? Is there any need to refill this? Let's kind of refill so that I won't be having unclear writing. We'll be going on to our next question about now. Alright, quickly refill this guy. Alright, let's see the next question we have on the board. Let's refill the other one too. This will take us to question number 10. Okay, we are going to question number 10 about now. Oops, So let's have it. For question number 10, we will read and then we will solve. The question reads, a ball thrown vertically upward, this is V, vertically upward, alright, returns to its starting point, Now guys, you know that this starting point, we can actually take it to be what? The ground, is it not? So you throw it, then you return to the ground. Okay? Now the question is, find, okay wait, they gave us time. Return to its starting point in 4 seconds. They gave us time in this very question. In 4 seconds. Okay, SEX. Now what is the question? Find, okay, its initial speed. Find its initial speed. This is what we are asked to find for this very question. Guys, how many value was given in this question? Okay, let me add, because normally this should always be there. G equals 10 meter per second squared. So guys, how many value do you think was given us in this very question? How many do you think was given us? Check it out. We were just given one value for this very question and we are asked to solve. So let's see what can be done to solve this question. Alright, let's see what can be done to solve this question. So we'll take our solution right away. Alright, we'll make use of a diagram so we can get what the question is saying very clear. Alright? Now this is it. Assume this is the ground level initially. Ground level. Now the ball was thrown from the ground. This is the ball. Okay? It was thrown from the ground. And then when the ball gets to its maximum height, what will happen? It will start coming down again. Alright? And this is the ball on the ground. Right? This is the general scenario. Upward and downward. Now this ball is moving under the influence of what? Gravity. It's moving under the influence of gravity. It's going up against gravity and coming down by gravity. It's going against gravity and coming down under gravity. Now this is what happened. They now said that the total time it takes for it to go up and come down is 4 seconds. Take note, the ball was thrown vertically upward, returns to its starting point in 4 seconds. They did not tell us how the time it takes the ball to go to the highest point. That was what they said. They said the time it takes to go up and come down. So total time is what? 4 seconds. Total time is 4 seconds. And you know we can't work with that. We have to get the time it takes to get to the maximum height. Okay? Let's call this total time big T. Alright, big T. How would I put it now? So therefore, big T is equal to what? 4 seconds. Now we don't work with this. The time it takes the ball to get to the maximum height is actually a small t. And from the small height to the ground is also a small t. So it is this small t plus small t that equals this big T. So how do we write that? Big T is equals to 2 small t. Okay, I hope that is clear. We have to get the small t before we find the initial speed. Just follow me. Now let's make small t subject. We'll say divide both sides by 2 over 2. Cancel, cancel. Small t is equal to big T over 2. So t is equal to, what is our big T? We said is what? 4. So 4 divided by 2. True or false? True. And what would that give us? That will give us also exactly 2 in seconds. So guys, you have gotten the small t that we actually will use to solve. Not the total time, but the time it takes to get to the maximum height. And this is the one we are working with. Clear? Good. So now we have this. What other things was given us? We've already gotten our, what do I call it? Small t from the big T. How do we know this is the big T? They said, a ball thrown vertically upward. Return. So, upward and return. It is for the total time. And that's not what we work with. We work with the time it takes to get to the highest point, or you can also call it the time it takes to return. It's the same value, abi? 2 plus 2, 4. So now we have already gotten that. We also told that this guy, the value for gravity here is 10 meter per second squared. True or false? True. And what are we also giving? We're also told that what for this same stuff, let me write this one under so that I can use this part of the board. We also told that we were told that gravity is 10 meter per second squared. Is it not? And not just that, guys. We also told something. Find its initial speed. So how do we symbolize initial speed? How do we symbolize initial speed? This is motion under gravity. In case you are asking, the topic is motion under gravity. Topic, in case you are asking, motion under gravity. Under gravity. So you can go and check it out. Okay? Motion under gravity. Now, we are asked to find the initial speed. What's the symbol for initial speed? Small u. And it's what? Unknown. Unknown. But do you know what? For motion under gravity, there are equations, about 4 of them. Okay? Now, each of the equations makes use of 4 quantity. So I'm saying 4 quantity per equation. But how many do we have? We have t, g, and u. Is it complete? No. So with all these 3 values, we cannot use any of the equation. We have to find a final value to make it 4. Now watch out something. Do you notice that when this ball gets to the maximum point, it does not have any velocity again? That's why I could not move up. It got to a maximum point and the final velocity become what? 0. So you now add final velocity symbolized by v equals 0 meter per second. Understand it too. The ball was thrown, it has a velocity, and that's the velocity we are finding. What is the initial velocity that it has? As it was moving against gravity, gravity is acting downward, it's trying to go against gravity. Its velocity starts what? Reducing. Then when you get to the maximum point, the velocity becomes what? 0. That's why I could not move higher than that. I hope you get. So final velocity is 0. This is, observe something. We're only giving 2 values. We have already got another value that was not given directly, but we were able to what? Derive it from the question. It has to be 4 values, 1, 2, 3, 4, before we can actually use any of the equations. If it's not up to 4, we cannot solve. So this is the last one I will complete it. So we can say at this place, v is equal to what? 0 meter per seconds. Are you seeing that? So because it has attained a value of 0, it does not have any strength to go higher than that. Gravity has overpowered it. What will gravity now do? It will now start pushing it down. So that's the downward motion you are seeing. Are you seeing that? Very easy. So we have 4 values. Now among the equation for motion under gravity, the one we are going to use, because we have g, we have t, we have u and v, the formula is, one we are using, is going to be v equals u plus or minus gt. Guys, you are making good progress. That is the formula on the board. Okay, you can check it out if you have not seen it before. Check the topic out. You'll get to see what I'm saying. It's v equals u plus or minus gt. Okay, it's kind of similar to the first equation for uniformly accelerated motion. Okay, but this is the counterpart we use for gravity. Now let's see. You are seeing 2 signs here, plus or minus. Guys, is it going to be plus or is it going to be minus? Which are we working with? Now observe, the ball was going first against gravity, is it not? Let's use that scenario. When the ball was going upward against gravity, okay, gravity will be negative. But if the ball is falling downward, gravity will be what? Positive. Take note of that. So let's assume the ball is going against gravity, this first case. So because of that, I will say what? Minus g. So against gravity, what symbol do you use? Because we have 2 options. Are we going to use plus or minus? Against gravity, you use what? Minus. Okay? Under gravity, okay, you use plus. So when they say the ball then drops under gravity, you use plus. Against gravity, use what? minus. So the first case, the ball was going against gravity. So let's use minus. We will write the equation V equals U minus GT. We have picked our final sign. What do? We have gotten the right formula. Is it not? This is the formula we're working with. So what do? We substitute these values into this. In place of V, we put what? 0, 0 equals to. In place of U, do we have a value for U yet? No, we'll leave it as U. They will say minus. What is our G? Our G is 10, so I'll put it in small brackets. 10 times. What is our small t? Check, the formula makes use of what? Small t, not the big T. Take note of that. So instead of t, we'll put what? 2. We'll put 2. I hope you understand it up to this very point. From here, we'll now say 0 equals U minus 10 times 2 is 20, like we know. So U minus 20 on the other side of the equation. We are looking for U, not U minus 20. So what do? Minus 20 will cross to this side of the equation so that U will stand on its own. How would that now look like? 0, when minus 20 cross the equality sign, it will become plus 20. So what will be left here is what? Just U. We can rewrite this by saying U is equals to 0 plus 20. It's the same thing. I just swap the equation. So I cannot say U is equals to 0 added to any number is that same number. So 0 plus 20 is 20 in meter per seconds. Why meter per seconds? Because that is the unit for what? Velocity or speed. So when they say find the initial speed, it will be what? In meter per second. So can you see that the question is very, very easy? Very, very easy. Just know how to do the same rules that applies to any question in physics. Just the same basic rule. So that is for that. That is for that. I trust you get how it was solved. Trust you get how it was solved. So we go on to the next question. The next question. Let's see what the next question will be on this part of the board. Or on this part of the board. We take the question right away. Right away. So this is the question. Question number 11. That will be question 11 for today. Question 11 for today. That is going to be our question 11. Let's see what our question 11 will be. Okay? Let's see what our question 11 will be. So we will be going on to question number 11 and see how we are going to solve it. Question 11, here we come. So this is question 11. It read kind of simple though. He said, question 11. The linear momentum. Okay, of a body is given as the product, okay, as the product, this is P, product of option A, mass and, let me just spell it out, mass and acceleration, option B, or you have mass and velocity, option C, you have force and distance, option D, you have force and velocity. So which of these formula is equals to linear momentum? That is the question. Which of this formula is equals to linear momentum? I trust we are still together on this. We will be answering this question right away. The question is the linear momentum. So we are looking for the one that is equals to what? Linear momentum. So let's go back it again. The linear momentum of a body is given as the product of what and what. So I've just answered the question straight without delay. Now, mass times acceleration is not equal to linear momentum. Rather, it is equals to force. So force is the product of what? Mass times acceleration. Mass times acceleration is equals to force. Now, this one is equals to momentum. Okay, take note. This is the answer to the question. Momentum is mass times velocity. Take note. Now, this one, force times distance is equals to moment. Moment of a body. Okay, force times distance. Force times distance is equals to what? Moment of a body. Now, this one is equals to power. Power. Normally, power is the time rate of doing work or expending energy. That is work over time or energy over time. But another formula for power is what? Force times velocity. So take note. So which should be our answer for this question? Option B. Very, very easy. Very, very simple and easy.
I hope that is clear to us. I hope that is clear to us. I trust you get how this was solved, okay? So let's see what we have for the next question. Question number 12. Question number 12. All right, let's see the next question. Question 12, we'll just put it here. They said the combination of sound waves with let's see, different. I don't think this is the question. Am I seeing it well? Oops. That is not it. Kind of a mistake. That is not the question. Okay, let's see the question. It said the ability of a wave to bend around obstacles in its path is called, this is the question, and we're given option A, we're told interference. Option B, we're told polarization. Option C, we're told diffraction. Okay, this is F. Sorry, stay with me. This is F, R. Diffraction. And option D, we're told refraction. So which of these is the answer? Which of these is the answer? That is the question we are asked to solve. Okay? It's basically not a solving question, it's just a reading and answering question. The ability of a wave to bend around obstacle. Ability of a wave to bend around obstacle in its path is called what? Like bending of wave around obstacle. What property of a wave is equivalent to that? That is the question. Now we know that there are basically 5 properties of a wave. We have reflection, R-E-F-L-E-C-T-I-O-N. Then we have refraction, we have interference, we have diffraction, and we have polarization. There are 5 properties of a wave. 5 properties of a wave. We have reflection, we have refraction, we have interference, we have diffraction, and we have polarization. Okay? Take note of that. These are the 5 properties of a wave. Now, the one that is equivalent to bending around obstacle, take note without wasting time, is option C. Okay? Option C. This one has to do with the ability of wave to get superimposed. Okay? Ability of wave to superimpose. Okay? On each other. That is this. Okay? That is for what I call it, interference. Then this is the ability of wave. Okay? Yeah, let me just see. This is change
in direction of a wave as it passes different medium. So the change in direction of a wave as it passes what? Different medium. Okay. This one is propagation of a wave. Propagation of a wave in a specific direction. So that is polarization. Initially, the wave was moving in many directions, but by using what they call a polarizer, as it passes through the polarizer, the wave will be moving in only one direction. So that is called polarization. That is called polarization. So take note of all this. So for this question, the answer is what? Diffraction. The ability of wave to bend around obstacle in their paths. Alright? So that is for that. That is for that. I clearly hope you understand how that was solved. I trust you understand how that was solved. So let's go straight to the next question without wasting much time, without further ado. Question number what? 13. We are going to question 13 right away. Question 13 is coming up right away on the board. Let's see what we have for question 13. Alright, we're about to answer the next question, which happens to be what? Question number 13. So let's take this question next. I think I've answered this one. If you've got any question, let me know in the comments. If you've got any question, let me know in the comment section. Alright, let's take this question. I just hope I've not solved it. That's why I'm kind of looking at it again. I hope we've not solved it, because they look like what we already solved in some other videos. Look like what we already solved. Alright, let's move on. We will be moving on to the next questions. Let me just go this way so I'll be safe. I don't want to just repeat the questions again, that's why I'm kind of checking. Okay. Alright, this next question would make sense. Let's do it now. The question read and we solve. This is the question, guys. They said, question 13. The question was saying, two simple pendula, pendula is because it's plural form of what? Pendulum. Two simple pendula, A and B. What happened to them? Makes oscillation. They make oscillations, alright, of 200 and 300. These are the oscillations they made, alright, respectively in equal time. Times, that was the put. Now what is the question, guys? It said, if the period of A is 1.2 seconds, the question is, what is the period of B? What is the period of B? What is the period of B? This is the question we are asked to solve. Alright, so this is the question we are being asked to solve on the board. So we will be solving it right away. I trust we are still following. If you have any question, like I said,
let me know in the comments section. Let me know in the comment section. So let's get started without delay. Like we have seen, this question is on simple pendulum. And what is the topic this simple pendulum is under? The topic, in case you are just seeing it and you are kind of inquisitive to ask, it's simple harmonic motion. That is the topic that this question is coming from. And basically, we're giving a comparative question. If this is for A, this is for B. If this is for A, what is for now B? I don't get me. A has this, B has this. If A now have this, what will B correspondingly have? That is the question. So we call it comparative question. They are comparing, is it not? First thing first, let's derive what I was given in this question. Two simple pendula, A and B, makes oscillation. Oscillation under simple harmonic motion is given by n, small n. This is not refractive index, okay? It's also the same symbol, n. It's oscillation. It stands for oscillation. N here stands for number of oscillation. Number of oscillation. So look at it, they say respectively. So A has this value, while B has this value. So we'll be using subscript here. N subscript A, they say the value is what? 200 oscillations. N subscript B, they say the value is what? 300 oscillations. Are you seeing that? It's clear, right? They said if the period of A, now we are giving period is capital T. So for A, we call it capital T subscript A. They said if that for A is 1.2, so we're told it's 1.2 seconds. What is the question? What is the period of B? So we'll come here, right? Capital T subscript B is unknown. The period of B is unknown. Now, among the formulas for simple pendulum, if you've watched the video I did under the topic simple harmonic motion, after the class you can check it out, okay? I gave formulas that if the question has this word simple pendulum or simple pendula, these are the formulas that applies. Okay, among those formulas, which one do you think we can use to solve this question? Is the one that says, okay, period is equals to, because we are comparing, let me just try the first formula first. Period is equals to small t over n. This is if you are finding for just one simple pendulum. Okay, this is the formula to use to get the period. Small t over n. But if you are finding for, let's say, a comparative case for pendulum A and pendulum B, you are comparing them. The formula will not be, because they said in equal time, so we'll take t to be constant. How will it not look like? T times n is equals to constant t. They said in equal time, so t is constant. So if t is constant, okay, we'll now look like t dot n equals k. Okay? Now it means that if you have T1 N1, it will be equal to what? T2 N2. So let me write that out. T1 N1 equals T. Now we are not working with 1 and 2, we are working with what? TA NA equals to what? TB NB. It's the same thing because we are saying A and B. Alright? So this is what we now have, and this is what we are going to be working with. If I wasn't patient enough, I could have stopped here. That's why you have to be patient with physics, step by step. Now, what is our TA? Our TA is 1.2. 1.2 times, what is our NA? Our NA is what? 200. What is our TB? Do we have a value for that yet? No value for that. So leave it as T subscript B. Times what is our NB? Our NB is what? 300. So we are making good and push progress. How do we make TB subject? Because that's what we are looking for. We'll divide both sides by what is attached to it. So here will be over 300 over 300. So 300 we cancel 300. TB will now be equals to, what do you have here on this part? 1.2 times 200 over 300. And let's use our calculator to get our final answer for this very question. 1.2
times 200, okay, divided by 300. Guys, our answer is 0.8. And what is the first TA? TA is in seconds. So our TB also be in what? Seconds. And that is the answer to the question. Like you can see, it's very, very simple and easy. It's never hard and it can never be made hard. Just know your formula and know how to manipulate. You are good to go. Alright, that is for question 13. We'll be moving on to the next question without further ado. So we don't waste time on this. Trying to pick out the questions that we'll need. Okay. Alright, I think we've seen one. Let's write it on this part of the board. Question 14. That will be our question number 14. Just know, anyone you are confused about, just ask about it in the comment section. Okay? Perhaps you watch the video later. You are just watching the video after the live session, and you are confused about anything, drop a comment. Definitely I will be notified and I will get back to you. Right? So let's progress. So question number 14. Question number 14. Let's see what we have for question 14. So this is question number 14, guys. Let's see what we have. So for question number 14, it's read and we solve. Question 14. Question 14. The question is a particle of charge. What's the charge? They said 5 coulombs. Coulombs is represented by C. Okay, coulombs. Okay, let me spell it in full in case you are just seeing it for the first time. This is coulombs. Moves at right angle. Okay, what happened to it? So a magnetic field. All right, let's rule of magnitude. What is the magnitude of the magnetic field? 0.01 Tesla. Tesla is the unit for magnetic field intensity, or what you call magnetic flux density. Either you call it magnetic field intensity or you say magnetic flux density, not intensity. Magnetic field intensity, or you call it magnetic flux density. Tesla is the unit for it. Okay. So what happened to it? They said it moves at right angle to a magnetic field. Okay. Then I said if the velocity of the charge, okay, what happened to the velocity is 1.5 meter per second. This is the velocity of the particle or the charge. Then I said, comma, the magnitude of the magnetic force on the particle is, so this is the question. We have to find the magnetic force. Forget about the long story. That is what we are asked to find. The magnitude of the magnetic force. So we say solution. So let's see how we can actually solve this. Kind of easy if you know the formula and how to derive. Like I said, that should be part of what you should learn. Okay? Now we go by the question and we derive. A particle of charge. First thing first, guys, we're given charge. What is the symbol for charge? Charge is given by Q, whether big Q or small q. The same thing we're talking about. Okay? Now they say that the charge of the particle is, or most especially the right unit for charge is small q. So just note. The value of the charge is what? 5 coulomb. Capital C stands for coulombs. Okay? Then I said the particle moves at right angle. So if the field is like this, the particle is moving like this. Clear? At right angle to a magnetic field of what? Magnetic. Okay, of magnitude. Oops. The magnetic field has a magnitude. It's magnitude that is here. Of magnitude. Okay, let's see what the magnitude is. They said the magnitude of the magnetic field is 0.01 Tesla. And the symbol for magnetic field intensity, because this Tesla, okay, is the unit for magnetic field intensity, or you call it magnetic flux density. The symbol for it is B, and they say the value for it is 0.01 Tesla. T for Tesla, capital T for Tesla. What else? They said if the velocity of the part of the charge, velocity is V, right? Small v. If the velocity of the charge is 1.5 meter per second, what is our question? The magnitude of the magnetic force. Magnetic force has the same unit as normal force, F. If you want to specify, you can have F subscript small m, but F is F. The value or the magnitude of the magnetic field is unknown. The magnitude of the magnetic field is force, the magnitude of the magnetic force is unknown. That way we have to find. Now we have Q, we have B, we have small v, we have to find F. Now if you study the topic in magnetism, force on a charge placed in a magnetic field, okay? Force on a charge placed in a magnetic field. You remember your flame is left-hand rule. Current, field, or force, and what? The field, okay? So if you are asked to find, what do you call it? CMM, CFM. If you are asked to find force on a charge that is placed in a magnetic field, how will you find it? How will you find it? How will you find it? The formula is this. F is equals to QVB. Okay? The full length of the formula, you add sine theta. But because we're not giving angle, we'll just use this. Clear? The full formula is QVB sine theta. But because we're not giving angle, theta, we'll just say, so therefore, F is equals to what? QVB. This is what we're going to work with. If there was angle, we use this. Clear? So let's substitute into the formula. F will now be equals to, in place of Q, we write what? 5. In place of V, we write what? 1.5. And in place of B, we add what? 0.01. So once you have gotten to this point, you are 99% done with the question. 99% done with the question. Okay? So that is what we have for now. Let's see what the answer will be. So we times and we get our answer. 5 times 1.5 times 0.01. Guys, our answer is, based on what I have here, that the force is equals to 0.075. And what is the unit for force? Force, like we all know, is in what? Newton, capital N. And this is the value for the magnetic force on the particle that is placed in the magnetic field. This is the answer to the question. So it's that easy, it's not difficult. I hope you are clear with this. If you are not clear, drop your queries in the comment section. Like always, drop your queries in the comment section. So we go straight to the next question. Let's see what we have here. All right, let's see what we have here. We are looking up for next question. Let's see what we have. Okay, let's see what we have. Yeah, 1, 2, 3, 4, 5, 6, 7. All right, let's see what we have. Basically, we can actually get to. Okay. So that's 16. 17, 18, 20. Yeah, let's see what we have basically. We will use this part of the board for the next questions. Alright, question number 14. No, 15 I mean. So we'll be solving question 15 on this part of the board. On this part of the board. So let's get to the next question, guys.
So like I said, if you have any question and you don't basically understand what we did, perhaps number 14, let me know in the comments.
So this is question 15 that we have to solve. The question read and we solve. They said, which of the following which of the following physical quantities is a scalar quantities? Is a scalar quantities. It's a scalar quantity, I mean. So let's just have it like this. Then we have question mark. A, we have force. Alright, B, we have displacement. Okay. This should be a walkover. Okay, it should be a walkover question. We have power. And D, we have momentum. So which of them is a scalar quantity? That is the question before us. So to get the one that is a scalar quantity, fine and clear, there's no fixed truth to knowing scalar and vector quantities. But with time, as you practice them, study your textbooks, you will kind of discover a pattern. I think anyone that ends with potential, example, electric potential, magnetic potential, whatever potential, they are always scalar, okay? Anyone that is containing the word flux density too, okay, there are things like that. Just check them out, okay? Check them out. Magnetic flux is potential, okay? But the field intensity, electric field intensity, so let me put this correctly. The one that ends with potential, they are always scalar, okay? The one that has field intensity, they are vectors, okay? There are other rules. Perhaps I'll work on a video on that and then we'll discuss them in details. So, but for now, let's get this one done with. They said, which of the following is a scalar quantity? So straight to the answer. We have force, we have displacement, we have, what else we have? We have power, and then we have momentum. So let's see which of them is a scalar quantity. So first is the product of mass times acceleration. Acceleration is a, what they call it, a vector quantity. So because of acceleration that is inside force become a what? A vector quantity. Force is a vector quantity. Okay? Now option next. Displacement is the distance traveled in a specified direction. So specified direction is there. It means that you don't just tell me the distance, you have to add the direction. So because of that, displacement is a vector quantity. Now what next? Power is in another form. No, power is just the rate of doing work, time rate of doing work. I only need the magnitude. You don't have to add the direction. So power is a scalar quantity. Now momentum is a product of mass times velocity. And velocity that is inside momentum is a vector quantity. So because of that, momentum becomes a what? A vector quantity. I hope this analysis is clear to us. I hope the analysis is kind of clear to us. If you don't understand, let me know. So guys, from this, what do you think our answer will be? Option A, B, C, or D? The answer is what? Option C. Very, very easy. Okay, very, very easy. So this will take us to the next question for today. Let's see what we have. It's getting easier with every question. It's getting easier with every single question. Okay? So let's see what our next question will be like. Then we solve and then we get our answers. Let's see what our next question will be like, guys. If you don't understand anything, perhaps you are watching this video some other time, be it this year, next month, next 2 years, drop a comment. God helping, I get a notification, I will get back to you, right? That is for that. So let's see our question number 16. Question 16. Alright, I think we are moving on to the last page of the record. So let's see the question here. It said the motion of the prongs of a tuning fork. This is tuning, okay, fork when struck is, so when the prong of a fork, you can see your normal fork, your spoon and whatever, but this one is a tuning fork. So when it's struck against a hard object, be it a wall or whatever, the motion that it observes is what? We're given options. So I have to add it. Random. So is it random motion? B, is it translational motion? Option C, is it what? Let's see what we have. Rotational motion. Is it rotational motion? Option D, is it vibratory motion? So which of them is the answer? That is the question we have before us. Okay? Now in random motion, listen, I'm explaining. For random motion, okay, let's clean this up so we can spell it correctly. For solution, let's just say solution basically, because I'm explaining now. So let's see what we have. For random motion, particles in this case move in no specific direction. So the direction of the particle is kind of haphazard. They don't have a specific direction. Okay, this is example your gas, what do you call it? Gas molecules. Okay, molecules of gas move in no specific direction. Okay. Your next, you have let's see, translational motion. All right. Now, will I call it particles now? The body, in this case, moves in a straight line. All right. So that is for what? Translational motion. Okay. E.g., a car along a road. The motion of a car along a road is translational motion, right? So what's next? We have the next one, rotational motion. This is the body, let's put it this way, the body moves about an axis. That is for rotational motion, about an axis. So if you check, this one in no specified direction, in a straight line, about an axis. Okay. For example, a rotating ceiling fan. Okay. That motion that the guy possesses is what? Rotational motion. Alright, last for this we have vibratory motion. Okay. Basically for vibratory motion, how are we going to put it? The body oscillates very fast. So to and fro motion very fast, and that's what you see when you struck the prongs of a tuning fork. So here we now add it, e.g. prongs of a tuning fork. So prongs of a tuning fork when struck. So this is the one that is the answer to the question. So basically you can just do your revision in case you just want to refresh your head about the types of motion. So there are other types of motion. So for this, our answer is going to be A, B, C, or D. The answer is what? Option D. That is it. That is it. So we move on. If you've got your questions, like I said before, ask them in the comment section. Ask them in the comment section. So this is the next question. Kind of interesting too. You will love this one. Let's see what the next question is. That's question 17 coming up, right? So let's see what question 17 will look like. So this is for the next question 17 that we have on the, we're about having on the board. It said question 17. Alright, so this is the question. Which of the following parts of the electromagnetic spectrum shows the widest separation? Widest separation. So we're given options like this. These were our options. So option A, it said sorry, it wasn't electromagnetic spectrum, guys. It was light spectrum. I will actually do a review. There is light spectrum, there is electromagnetic spectrum. So in this case, the question was for light spectrum. Which of the following parts of the white light spectrum shows the widest separation? So this is our question, guys. Observe the change or the correction. So option A, let's see what our options were. They said yellow and red. Option B, they said orange and green. Option C, they said blue and green. Let me put this on a small letter. Blue and green. And lastly, option D, they said red and indigo. So this is the question before us. And how are we going to answer it? How are we basically going to answer this question? So this is it. There is something called white light spectrum. White light or visible light is a part of electromagnetic spectrum. And on its own, it has its own spectrum. When you say spectrum, separation, okay? Like something is divided into many, okay? We know that normally the electromagnetic spectrum is like this. Let's do something kind of dramatic. Electromagnetic spectrum. For your electromagnetic spectrum, okay, we said we have gamma ray, we have X-ray, let me add ray. Then after GX, we have ultraviolet wave, we have, after ultraviolet, we have visible light. This is one that we are talking about. Visible light. Remember, it's GAOXU. What do you call it? L. This is one that they use. You can also call it. Is one also called in one of the live session light wave. It's same thing as visible light or white light. They are all the same thing. Okay. And after that, let me just write one. Light wave. So that, because some of you cramp the acronym, right? So light wave, then this is ultraviolet wave. Then after that you have GAUX, ULI, infrared. You have infrared wave is a wave. Then lastly you have radio wave. Now watch out, this is the component of electromagnetic spectrum. This guy, this, and this. Now you see this one in the, should I say, is in the middle now. This fourth guy called the light wave. It then kind of differentiates into its own spectrum. That's what we are talking about. We now call it the light wave spectrum, or the white light spectrum, or visible light spectrum. The same thing we're talking about. So we now say, what is it? Remember, you have ultraviolet. Are you seeing that? Infrared. Normally, I was supposed to start from a pattern, but I have to follow the way it's arranged. So I will say, instead of ROYGBIV, this is for, what do you call it? Light wave spectrum. Light spectrum. Alright, let me just put it in another way. Let me just write it this way. This will be better. Light spectrum. We're talking about light spectrum now. Like I said something. I said light wave is a component of electromagnetic spectrum, and on its own it also have spectrum, and it's under electromagnetic spectrum, but it also has its own spectrum. So it is given by this, what I call it, abbreviation, ROYGBIV. But this is how it is arranged. V. So we are starting from this place back to arrow because of this arrow. See, it's V to arrow. So we are starting from this place back to this place. So we say violet. These are the spectrum of white light. Then we have I, indigo. Then we have B, blue. Then we have G, green. Then we have Y, yellow. Then we have O, orange. And lastly, we have R, red. So these are the components of visible light. Okay. Now the question before us is, which of these options show the widest separation or are far apart? Option A, we are now working with this now, not this. They can also say which of the electromagnetic spectrum show the widest separation. So you'll be comparing. Yes, so if they say option A, gamma, and this, you check, okay, there's only one in between. So it's kind of close. But now we are using for light spectrum, not for electromagnetic spectrum. So option A, yellow and red. Where is yellow? This. Where is red? This. How many guys in between? Just one. Take note of that. Option B, orange and green. Orange and green. So how many guys in between? It's just the one. Option C, blue and green. This is blue and this is green. How many guys in between? No guys in between. Option D, we have red and indigo. You have seen the distance between red and indigo. How many is in between? 1, 2, 3, 4. So which of them show the widest separation? It's not option D. Yes. And this is the answer to the question. Very, very simple and easy. I suppose you understand how this question was solved, right? That is for that. Okay? That is for that. So straight to the next. Alright, so we will be taking this next question right away. On this part of the board. Let's see question 18. Question number 18 on this part of the board. Question 18 on this part of the board. Question 18 on this part of the board. Alright, so let's see what we have right away. Alright, so this is question 18. We just write it out. 18, they said the units of inductance and reactance. So we have two quantities here, two physical quantities, inductors and reactants, are respectively. So you don't just tell me their unit, but you arrange them in the order they were asked. inductance first before reactance. So what are the options? Option A, they said, is it Holmes and Henry